Good day, everyone. I am Reina Maridi Bisaya, and I'm going to discuss the 5 selected items from our problem set. In this item, we are going to use the Gauss-Jordan elimination in each of the following system of linear equations. So I have chosen the letter D. 2x sub 1 plus 2x sub 2 plus 2x sub 3 is equals to 0. Negative 2x sub 1 plus 5x sub 2 plus 2x sub 3 is equals to 1. 8x sub 1 plus x sub 2 plus 4x sub 3 is equals to negative 1. So we are going to convert the system into an augmented matrix for Gaussian elimination. So we are going to convert the system into an augmented matrix for Gauss-Jordan elimination. So we have our column 1, 2, negative 2, and 8. For column 2, 2, 5, and 1. For column 3, 2, 2, and 4. And for our last column, we have 0, 1, and negative 1. In simplifying the row 1, we have to divide row 1 by 2 to create a leading 1. And by dividing it, we have the new row 1, 1, 1, and 0. Just copy the row 2 and row 3. Now we are going to create zeros below the leading 1 in row 1. So for row 2, we have to add 2 by row 1 to row 2 and subtract 8 by row 1 from row 3. So we have here our updated matrix. For column 1, 1, 0, and 0. For column 2, 1, 7, negative 7. For column 3, 1, 4, negative 4. And for the last column, we have 0, 1, and negative 1. Now to create a leading 1 in row 2, we are going to divide row 2 by 7. And by dividing it, we arrive at our answer. The new row 2 is 0, 1, 4 over 7, and 1 over 7. And now we are going to create zeros in column 2 except for the row 2. So for row 1, we have to subtract row 1 by the row 2. And for row 3, we are going to add row 3 by 7 and multiply it by row 2. Now, our updated matrix, the reduced row echelon form, we have the column 1, 1, 0, and 0. Column 2, 0, 1, and 0. For column 3, 3 over 7, 4 over 7, and 0. And for the last column, we have negative 1 over 7, 1 over 7, and 0. As you can see, the system is dependent. In row 3, it is all zeros. So we are going to express solutions in terms of a free variable. So from row 1 and row 2, x sub 1 plus 3 over 7, x sub 3 equals negative 1 over 7. So that will become x sub 1 is equals to negative 1 over 7 minus 3 over 7 x sub 3. For row 2, we have x sub 2 plus 4 over 7 x sub 3 is equals to 1 over 7. And that is equals to x sub 2 is equals to 1 over 7 minus 4 over 7 x sub 3. Now we are going to let the x sub 3 is equals to t, where t is an element of real number. Then we have x sub 1 is equals to negative 1 over 7 minus 3 over 7t. X sub 2 is equals to 1 over 7 minus 4 over 7t. And x sub 3 is equals to t. For our item number 2, so I have chosen number 2, letter H. We are going to perform the indicated operation on the following matrices. So for number 2, letter H, the transpose of a matrix D minus the transpose of a matrix E. Our given matrices, D is equals to The column 1, 1, negative 1, and 3. Column 2, we have 5, 0, and 2. For column 3, we have 2, 1, and 4. And for our matrix E, column 1, we have 6, negative 1, and 4. Column 2, we have 1, 1, and 1. And for column 3, we have 3, 2, and 3. The transpose of a matrix D minus the transpose of a matrix E is equals to column 1, 1, negative 1, and 3. Column 2, 5, 0, and 2. Column 3, 2, 1, and 4. Minus the column 1, the other matrix, 6, negative 1, and 4. Column 2, we have 1, 1, and 1. And column 3, we have 3, 2, and 3. The transpose of a matrix swaps its rows and columns. So for our D, the transpose of a matrix D is equals to column 1, 1, 5, and 2. Column 2, negative 1, 0, and 1. Column 3, 3, 2, and 4. Minus the other matrix, the transpose of a matrix E. We have the column 1, 6, 1, and 3. Column 2, negative 1, 1, and 2. Column 3, 4, 1, and 3. As you can see, the first row of D and E becomes the first column of the transpose of a matrix D and also E. Now we are going to subtract the corresponding elements of the transpose of a matrix D from the transpose of a matrix E. So, we have here column 1, 1 minus 6, 5 minus 1, and 2 minus 3. For column 2, we have negative 1 minus negative 1, 0 minus 1, 1 minus 2. And for column 3, we have 3 minus 4, 2 minus 1, and 4 minus 3. Are just going to subtract the column 1 of our matrix in D from the column 1 in the matrix of our E. Now we are going to simplify each. For our first row, we have 1 minus 6 and that is negative 5. Negative 1 minus negative 1, that is 0. 3 minus 4, that is negative 1. For our row 2, we have 5 minus 1, that is equals to 4. 0 minus 1, that is equals to negative 1. And 2 minus 1, that is equals to 1. And for our third and last row, we have 2 minus 3, that is negative 1. 1 minus 2 is equals negative 1. And 4 minus 3 is 1. So our final matrix or the final answer, the transpose of a matrix D minus the transpose of a matrix E is equals to the column 1 we have negative 5, 4, and negative 1. Column 2 we have 0, negative 1, and negative 1. Column 3 we have negative 1, 1, and 1. For our third item, so I have chosen number 5 letter B. And we are going to solve the linear system by using the Cramer's rule. 2x sub 1 plus x sub 2 plus x sub 3 is equals to 6. 3x sub 1 plus 2x sub 2 minus 2x sub 3 is equals to negative 2. X sub 1 plus x sub 2 plus 2x sub 3 is equals to negative 4. Now we are going to write the coefficient of the matrix A. So we have A is equals to in column 1, we have 2, 3, and 1. Column 2, we have 1, 2, and 1. Column 3, we have 1, negative 2, and 2. First, we are going to calculate the determinant of A. The determinant of A is equals to this matrix. The column 1, we have 2, 3, and 1. Column 2, 1, 2, and 1. Column 3, 1, negative 2, and 2. But before that, let us see how to calculate the Cramer's rule. To avoid errors, we are going to extend the matrix by repeating the first two columns. So we are going to subtract the sum of our forward diagonals from the sum of the backward diagonals. So our forward diagonals, the primary diagonal, we have A sub 11. times a sub 22 times a sub 33 plus the next diagonal, we have a sub 12 times a sub 23 times a sub 31 plus the last diagonal, we have a sub 13 times a sub 21 times a sub 32. And for our backward diagonal, we have a sub 13 times a sub 22 times a sub 31 plus the next diagonal, a sub 11 times a sub 23 times a sub 32 plus the last diagonal, we have a sub 12 times a sub 21 and times a sub 33. As what I have stated earlier, in determining the determinant of a, we are just going to subtract the sum of the forward diagonals from the sum of the backward diagonals. So we have here the determinant of a is equals to this matrix. The column 1, we have 2, 3, and 1. Column 2, we have 1, 2, and 1. Column 3, we have 1, negative 2, and 2. By applying the determinant, so we have arrived at this solution. The determinant of a is equals to 8 plus negative 2 plus 3 minus 2 plus negative 4 plus 6, and that is equals to 5. So our determinant of a is 5. Next, we are going to find the determinant of a sub 1. So we have this matrix. We have the column 1, 6, negative 2, and 4. Column 2, we have 1, 2, and 1. Column 3, we have 1, negative 2, and 2. By applying the determinant, so we have arrived at this solution. So the determinant of a sub 1 is equals to 24 plus 8 plus negative 2 minus negative 8 plus negative 12 plus negative 4, and that is 54. So our determinant for a sub 1 is equals to 54. Next, we are going to find the determinant of a sub 2. The determinant of a sub 2 is equals to this matrix. We have the column 1, 2, 3, and 1. Column 2, we have 6, negative 2, and 4. Column 3, we have 1, negative 2, and 2. By applying the determinant, so we have arrived at this solution. The determinant of a sub 2 is equals to 8 plus negative 12 plus negative 12 minus negative 12 plus 16 plus 36, and that is negative 82. So our determinant for a sub 2 is equals to negative 82. Next, we have a sub 3. The determinant of a sub 3 is equals to this matrix. We have the column 1, 2, 3, and 1. Column 2, 1, 2, and 1. Column 3, we have 6, negative 2, and 4. By applying the determinant, so we have arrived at this solution. The determinant of a sub 3 is equals to negative 16 plus negative 2 plus 18 minus 12 plus negative 4 plus negative 12, and that is 4. So our determinant for a sub 3 is equals to 4. Now, we are going to solve for x sub 1, x sub 2, and x sub 3. Using the Cramer's rule, we have a x sub 1 is equals to the determinant of a sub 1 over the determinant of a, and our determinant for a sub 1 is 54, and the determinant of a is 5. So 54 over 5 for x sub 1. Next, for x sub 2, we have x sub 2 is equals to the determinant of a sub 2 over the determinant of a. So we have negative 82 over 5. And next, for x sub 3 is equals to the determinant of a sub 3 over the determinant of a. So we have 4 over 5. Our solution to the system is x sub 1 is equals to 54 over 5, x sub 2 is equals to negative 82 over 5, and x sub 3 is equals to 4 over 5. For our next item, so I have chosen number 6. Given the matrix below, determine the following cofactors and find its determinant. So we are going to find the cofactors for number 4, A sub 41. So we have here our matrix. A is equals to the matrix. Column 1 we have 1, 2, 3, and 0. Column 2 we have 0, 1, 2, and 3. Column 3 we have 3, negative 4, 4, and 1. Column 4 we have 0, negative 1, 0, and 0. A sub 41 is the cofactor of the element in row 4, column 1 of the original matrix. As you can see, our row 4, we have 0, 3, negative 1, and 0. And our column 1, we have 1, 2, 3, and 0. Our row 4, column 1 is equals to 0 from the given matrix. So we are going to delete the row 4 and column 1. Now we are going to compute the determinant of the submatrix or the minor. So M sub 41 is equals to this matrix. The column 1 we have 0, 1, and 2. Column 2 we have 3, negative 4, and 4. Column 3 we have 0, negative 1, and 0. So our formula for the cofactor, we have A sub ij is equals to negative 1 raised to I plus j times the M ij. A sub ij, this is the cofactor of the element at row I, column j, and Mij or M sub ij is the minor, the determinant of the submatrix formed by deleting row I and column j. Our negative 1 raised to I plus j here is our sign factor. So A sub ij is equals to negative 1 raised to I plus j times M sub ij. So negative 1 raised to 4 plus 1 since our I is 4 and j is 1 column, that is column 1, and M sub ij, that is the determinant of our matrix. And by applying the determinant, so we have arrived at this solution. So negative 1 raised to 5 times negative 6, and that is 6. So our final answer, A sub 41 is equals to 6. For our last item, do the polynomials t cubed plus 2t plus 1, t squared minus t plus 2, t cubed plus 2, negative t cubed plus t squared minus 5t plus 2 span p sub 3. So our matrix A is equals to this matrix. The column 1 we have 1, 0, 2, and 1. Column 2 we have 0, 1, negative 1, and 2. Column 3 we have 1, 0, 0, and 2. Column 4 we have negative 1, 1, negative 5, and 2. A, B, C, and D, that is our x, the vector of our unknowns. Now we are going to perform the Gaussian elimination to transform A into row echelon form to solve for our x. Since in our row 1, we already have our leading 1, and the row 2, the below of the leading 1 is already 0. So now we are just going to compute the row 3, column 1, and row 4, column 1. That must be 0. So we are going to subtract row 3 from 2 times the row 1 and row 4 minus the row 1. So we have here our new matrix. A is equals to the column 1 we have 1, 0, 0, and 0. Column 2 we have 0, 1, negative 1, and 2. Column 3 we have 1, 0, negative 2, and 1. And column 4 we have negative 1, 1, negative 3, and 3. And the last column we have A, B, C minus 2A, since our row 3 is C and our row 1 is A. D minus A, since our row 4 is D and our row 1 is A. So now we are going to add row 3 by row 2 so that the below of our leading 1 will become 0. And subtract row 4 by 2 times the row 2. So our new matrix, we have A is equals to the column 1, we have 1, 0, 0, and 0. Column 2, we have 0, 1, 0, and 0. Column 3, we have 1, 0, negative 2, and 1. Column 4, we have negative 1, 1, negative 2, and 1. And our last column, we have A, B, C minus 2A plus B since our row 2 is equals to B, and D minus A minus 2B since our row 4 is already D minus A minus 2 and our row 2 is B. Next, now we are going to divide our row 3 by negative 2 so that our row 3 column 3 will become 0. Now we are going to divide row 3 by negative 2 so that we will have our leading 1. So our new matrix, we have A is equals to this matrix. The column 1, we have 1, 0, 0, and 0. Column 2, we have 0, 1, 0, and 0. Column 3, we have 1, 0, 1, and 1. Column 4, we have negative 1, 1, 1, and 1. And the last column, we have A and B, negative C over 2 minus A minus B over 2. It is because our row 3, which is C minus 2A plus B, is divided by negative 2. Now we are going to subtract row 1 by row 4 and subtract also row 4 by the row 3. So our new matrix, we have this. A is equals to this matrix. The column 1, we have 1, 0, 0, and 0. Column 2, we have 0, 1, 0, and 0. Column 3, we have 0, 0, 1, and 0. Column 4, we have negative 2, 1, 1, and 0. Our last column, we have, since our row 1 is A and our row 4 is D minus A minus 2B, so we are going to subtract A from our row 4, which is D minus A minus 2B. So we arrive at this solution, 2A plus 2B minus D. And just copy the row 2, which is B, and also the row 3, which is negative C over 2 minus A minus B over 2. So our row 4, we have to subtract it. Since our row 4 is D minus A minus 2B, we are going to subtract it from our row 3, which is negative C over 2 minus A minus B over 2. So we have arrived at this solution. We have negative 2A minus 3B over 2 plus C over 2 plus D. Therefore, the given polynomial does not span P sub 3. That's all for today. I hope you learned something from me. Thank you for watching and God bless us all.